Okay, so yesterday we talked about identifying the outcomes of compound events. So we used a tree diagram, we used a table, we used ordered lists or organized lists. Okay? So today we're going to focus on finding the probability of those compound events. And we kind of looked at that yesterday with Chipotle, where we found the total number of outcomes. Now, we figured out there was like 116,000 different combinations or something like that, right? I thought. Your order at Chipotle is unique to you, correct? Okay? Very few people are going to have the exact same order than you. If we talk about the probability of your burrito artist getting your order correct, we're talking about a 1 in 116,000 chance, because your order is unique to you. So that would be the probability. Now that's like probably like 0.0000 some percent, right? So that's what we're going to focus on today. Finding the outcomes of compound events and calculating the probability of that event happening. Okay? So our first example says find the probability of compound events using a table. Sadie has 1 ticket left at the school fair, and she has yet to win. She is deciding between 2 games. Which should she choose? Okay. So the first game is flip to win. You have to flip 2 heads to win a prize. The second game is flip and spin. Flip a head and spin blue to win a prize. Okay. So right off the bat, how many outcomes are there for this event? Are you sure?
4.
Why 4?
So there's a head side and a tail side.
Okay, so you have to flip 2 heads to win, right? So there's 4 different outcomes. How many different outcomes are here?
2, 5, 8.
Okay, why 8?
Because there's 4 different colors on the wheel, and then there's 2 different sides to the coin.
Okay, so the outcome for flipping for flipping a coin is 2. Outcome for spinning is going to be 4. So 2 times 4 is
8.
So we talked about that yesterday. We talked about the counting principle. We can calculate the number of outcomes even before we begin. Now we have to have specific outcomes to understand the probability of the outcomes. So let's create our tables. Flip to win. So event 1 can go on your horizontal, event 2 can go on your vertical. So event 1, we can get a heads or a tails. Event 2, we can also get a heads or a tails. So we can get heads, heads, or we can go heads, tails. Then we can go tails, heads, or we can go tails, tails. So again, it's kind of like a multiplication chart, right? How does she win? How does Sadie win? 2 heads, right? So for the flip to win, our probability of flipping heads, then heads. How many total outcomes are there? 4. So that is our numerator or denominator? Denominator. How many ways can she get heads, heads?
1.
Only 1 way. So the probability of her flipping or her winning is 25%. Are we taking that bet? It's only 1 ticket, right? But she don't win anything all day. Boo. You know what my favorite game is? The goldfish game.
That game's so wild, though. It's where they have like thing with goldfish in the top.
It's like all the, they've got all those bowls sitting out, you know?
And they float around.
And you either have to, like, it's either a ping pong ball or it's a ring, and you gotta get it in. I like that one.
Remember one time I won that and I got a goldfish?
Those are really skill-based.
It died. Oh yeah, absolutely. All right, so our next one is flip and spin. So flip and spin. So again, we're drawing a table. We can flip a heads or a tails. And then we can spin a red, yellow, blue, or green. Right away, what do you notice? Is your probability going to be greater for flip to win or flip to spin?
Flip to win. Not
Okay.
flip.
Why do you think flip to win, Craig?
Because it has more outcomes than flip to win.
Okay, so flip to spin has more outcomes than flip to win. Okay, so that gives our number of outcomes is greater. So that means our chances to win are probably going to be low. Okay, so when we look at our table, we flip a heads, spin red, flip tails, spin red. Is that going to help us? It's not going to help Sadie, is it? Nope. Then she can flip heads, spin yellow, flip tails, spin yellow. So already out of our 4 options, does she have a chance to win?
No.
No. So our next one is flip heads, spin blue, flip tails, spin blue. Now do we have a chance to win?
Yes.
We do, because she has to flip a head and spin a blue. How many options are we at?
6.
And there's only one way that she can win. So even without finishing the table, we're at 1/6. Which is the better option for her to win?
Flip to win.
Flip to win. Okay. So when we finish the table, heads in green, tails in green. So the probability for flip to spin, she has to get a heads and blue. There are 8 total outcomes, and how many ways can she win?
1.
Only one. So in your calculators, 1 divided by 8, that's going to give you your decimal, which we then convert to our decimal. Okay, it's going to give us our, it's going to give us our decimal, which then we scoop. So 1/8 125 thousandths. So as a percent, it's about 12.5%. So not only are we finding the outcomes, but then we're finding the probability of our outcomes. So that's using a table. This one we are going to add, I forgot a chunk of the problem. So the next one we're going to look at is finding the probability of compound events using a tree diagram. What is the probability of, let me see. What is the probability one coin flipped 3 times, so you're going to add that into your notes, will land heads up exactly 2 times? So what is the probability one coin flipped 3 times will land heads up exactly 2 times? What happens on flip 1? What can happen on flip 1? Gabrielle?
You can get a head or
Heads or tails, right? So now what do? You gotta go again, right? So then flip 2, what are our options? Okay, so we can go, if we get a heads, then we can go heads or tails. If we get a tails, we can go heads or tails. Now with flip 3, do our options change? No, because our coin doesn't change, right? So now we can go heads, heads, and flip 3, we can go heads or tails. Heads, tails, heads or tails. And then we go this way. Tails, we can go heads or tails. Tails, tails, we can go heads or tails. Now when we're using the tree diagram to figure out our possible outcomes, we always count the bottom row. So we have 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 possible outcomes of this event. So the probability that we're trying to find is at least 2 heads, right? And we know there are 8 possible outcomes. Okay. So what about our first one? Heads, heads, heads. Does that work?
Yes.
Because that's at least 2, right? Okay. Now this one is heads, heads, tails.
That still works.
That still works because it says at least 2. Okay. Heads, tails, heads works, right?
Wait, isn't it exactly 2 times?
No, it can be at least.
Oh, you're right. Back up. Good job. Back up. I mean, this is totally what I meant. Okay, sorry. Try again. All right. Heads, heads, heads. Does that one work?
No.
No. Okay. Heads, heads, tails.
Yes.
That one works. All right, here's our next one. Heads, tails, heads. That one works. There. Okay. Now, heads, tails, tails.
No.
Doesn't work. All right. Tails, heads, heads.
Yes.
Tails, heads, tails.
No.
Tails, tails, heads.
No.
Tails, tails, tails.
No.
So how many do we have?
3.
3 out of 8. Okay. So the probability that we get exactly 2 heads is 3 out of 8, which is 37.5%. So 3. How? Okay, so 3/8 is 375 thousandths. So then to convert to our percent, 1, 2, we get 37.5. Do I care which form you put it in? Okay. Someone somewhere might. They might say, you know, as a percent or as, you know, as a decimal, as a fraction. I don't care. You can use any one of those because they are equivalent. So it does not matter to me which one you use.
Is the state test gonna make us put it in?
Usually the state test does not, they don't require you to put in any certain form. So you could choose which one you wanted. Usually. We know with Pearson though, sometimes it says it in gray, like as an integer, as a decimal, as a mixed number. So just make sure you look for those cues on the test, okay?
Is like the state test gonna have a calculator?
Day 1, no. Day 2, yes.
Why not day 1? So are we gonna bring our own calculator?
On day 2, yes. Day 1, you are not allowed to use a calculator at all.
Don't they provide you calculators sometimes for some questions?
That's on the MAP test. The state test, day 1 is no calculator. A calculator won't pop up, you can't use a calculator. Day 2, a calculator is on the test, or you can use a handheld calculator. You can't use Desmos, you cannot use your phone, you can't, the computer is locked, so you can't get on Desmos. So if you have a handheld calculator, you're gonna wanna bring it for that day, for the 28th. 28th?
You said the state test calculator is the Desmos calculator?
For the algebra test, yes. I don't know if it is for for our test. It might just be like a 4-function calculator, like the one that pops up on MAPS testing without a fraction. So that's why a handheld calculator is really good and really useful to have, because you can do calculators. You can do calculators. You can do fractions on those calculators. So if you have one, dig it out, right? Get in the bottom of your book bag. Stop being lazy.
Isn't that testing next week or next week?
Both.
Reading is next week, the 13th and 14th. No, 14th and 15th. And then you have a week off. And then the next week you have math on Tuesday and Wednesday. So the 27th and 28th. And then if you take 8th grade science, you have that one on Friday. Yes. Okay, last problem. The names of several middle school students were entered into a drawing for one of 2 baseball tickets. This year, Angie, Mark, Phil, Josie, and Carly were entered into the drawing. What is the probability that Mark's name will be drawn to win one of the tickets? So, if Angie's drawn first, who can be chosen after Angie? Okay, so Angie can be chosen with Mark. Angie can also be chosen with, Angie can be chosen with, and then Angie can be chosen with Carly, right? What if Mark is chosen first?
Then
Who else can go with Mark?
Angie, Phil, Josie, and
Right.
Josie.
So Mark and Angie can be chosen. Mark and Phil can be chosen. Mark and Josie can be chosen. Mark and Carly can be chosen. So now, who gets chosen?
Phil.
Okay, so if Phil gets chosen first, Phil and Angie, Phil and Mark, Phil and Josie, Phil and Carly. Now we go to Josie. And then we end with Carly. How many different possibilities are there? 20, right? Okay, because when we think, this is like an array. Remember doing arrays? Okay, there are 4 here and then 5 here, so 4 times 5. Okay, so the probability that Mark gets chosen out of 20. Okay, so now we got to look at all the times that Mark gets to go to the game. He can go with Angie. He can go with Phil, Josie, and Carl. Phil can go with Mark. Josie can go with Mark. Carly can go with Mark. So anytime an M pops up on your list, that means that Mark gets to go, right? So out of the 20 times, how many times does Mark get to go?
8.
He gets to go 8 times.
We can't really go at all with COVID.
Not much to live in Texas, huh?
Yeah. What? That makes me so mad.
State English left at 4 now.
What?
I don't understand where they looked at that,
Okay, so 8 divided by 20 is 4/10, which is 40%. Does only Mark have a 40% chance to go? Everybody has a 40% chance of getting to go to the game. Right? Because they all have, there's 8 different ways that everyone can go. All right, so your homework tonight, 3 problems again. Okay. So we've got fair coin being tossed. We've got a tree diagram with 2-digit numbers. And then we've got a cube being rolled 2 different times. First roll and second roll. Okay? So 3 problems. You have 10 minutes.